This video is for integrated 2. This is the chapter 11 D-Day number 1. So on this first problem, we have a circle with two chords that are intersecting. And when we have two chords that are intersecting, what's going to happen is the sections, okay, the segments that are formed, this segment here and this segment here, if I multiply those together, it's going to be the same as this segment here times this segment here, okay? So let me fill in what I know. I know AE is 2 and AD is 10. So AE is 2 and AD, which is going to be all the way from here to here, is 10, which means that ED is going to be the rest of that 10, which is an 8. They tell us that BE is 12. So this one here is 12. And I want to find EC, which I'm just going to call X. So, whoops, hold on. I wanted to color code. Apologize. Just trying to keep things straight. What's what? Okay, so this is the teal piece. Okay, so this is 12. So I am going to multiply the AD, those two segments, AE, which is 2, times ED, which is 8. And that product needs to be the same as the other two segments multiplied together, which is going to be 12, which is EB, and X, which is EC. And that's what I'm trying to find. So I'm going to end up with 16 is equal to 12x. I divide by 12, I get 16/12. And if I reduce that by 4, that is going to be 4/3. And that is the length of EC. On number 2, in this situation, I know that the center of the circle is C. And I know CD, which is this radius actually of the circle, is 7, which means I'm just going to do it in a different color, that this is also 7 because that's also going to be a radius. Something else I know is that when I have a chord, and the chord I'm trying to find is this chord right here. I want the length of A to B. But when that chord is being intersected in a perpendicular manner, as it is with this FC here, okay, it is perpendicular. It ends up being a perpendicular bisector. So this and this are going to be the same. So I'm going to say that this right here, let's say, is X, which means that, sorry, this right here is X, which means that this side here is also going to be that same length X because it's bisecting it, okay? And together, those added up is going to be AB. So what you'll notice is I do have a right triangle, okay? That is going to be my A to E, which I'm going to call X. This is going to be my E to C, which I know is 3. And then this right here, A to C, I know is 7. And this again is where my right angle is. So I'm going to do Pythagorean theorem. A squared plus B squared equals C squared. My hypotenuse is the 7. So actually I'm going to go 7 squared minus 3 squared is going to equal X squared. So that's going to be a 49 minus 9, which is going to be 40 is equal to X squared. I take the square root of that, and I get the square root of 40 is equal to X. We want to start cleaning these things up. So when I'm cleaning this up, realize that this is really a root 4 times a root 10, which is a 2 root 10. Okay. So I have that 2 root 10 from A to E, but I also have that from E to B. So that whole line segment is going to end up being 2 times 2 root 10 which is going to be 4 root 10. And that is going to be the length of AB, 4 root 10. So our next problem on this one, a couple things I know. I know that EG is the diameter. So going all the way across here, that is our center, okay, and that is our diameter. I also know that measure of arc FG, okay, the arc measure, this right here, is going to be 39 degrees. I know that this arc measure, E to H, is going to be 50 degrees. And they want us to find two things, measure of angle E. So if I draw out angle E, I'm going to do it in a highlight. I'm doing it in a purple highlight. So measure of angle E is going to be this to this. And you'll notice that that is forming that intercepted arc that's 39 degrees. So this inscribed angle is going to be half of 39 degrees. And so when I take half of 39 degrees, I'm going to end up with 19.5 degrees for that angle. Now, I also need to find measure of angle. Measure of angle GPF. So that one, GPF, let me just get rid of this for a second. And so GPF is that angle. Now, what's happening is that angle is formed by the intersection of two chords, okay? I have the orange chord and I have this red chord that are forming that angle. Those two lines are also, our chords are also forming the 50 degrees and the 39 degree arcs. So if I'm trying to find this angle right here, I'll do it in, I'll just do it in black, this angle right here. What I'm going to do is I'm going to take the intercepted arcs that the two chords that form that angle also form, the 50 degrees plus the 39 degrees. I'm going to add them up, divide by 2. And that is going to give me what I want. So it's going to be 89 degrees divided by 2, and that is going to be 44.5 degrees. So on number 4, we're going to be finding the intersection of the parabola and the line. So when I do this, they want us to do this algebraically, okay? Not using Desmos. So I'm going to go 3x squared plus 8x minus 11, and I'm going to use equal values. Since they both equal y, they're going to equal each other. So I get negative x plus 3. I'm going to get everything on one side, 0 on the other. So I'm going to keep my 3x squared here. I'm going to add x to both sides, getting a 9x. I'm going to minus 3 from both sides, which is a negative 14 equals 0. Now, I'm going to real quick see if it's factorable, okay? So if it's factorable, what should be true is that if I multiply these two together, the 3 and the negative 14, okay, so that would give me a negative 42. It needs to add to this 9x. And so I want to think, does anything multiply to negative 42 and add to 9? So I'm just going to systematically list things. Now, one would be a positive, one would be a negative. So I would be really subtracting to 9. So 1 and 42, well, that's not going to subtract to a 9. 2 and 21, that's not going to subtract to a 9. 3 and 14, that subtracts to 11, not a 9. 4 doesn't go into 42 evenly, 5 doesn't, 6 does, 7 times. And then the next number would be 7 times 6. So I've listed all of them. None of these are going to subtract and give me a 9. So I'm going to use quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, this wasn't factorable, but just because it's not factorable does not mean it's not solvable. So I'm going to put in negative 9 plus or minus the square root. 9 squared, which is an 81, minus 4 times my a, which is 3, and my c, which is a negative 14. And then this is all going to be all over 2 times my a, which is 3. So let me do a little math here. This is going to be a negative 9 plus or minus the square root. And when I put this in my calculator, 81 minus 4 times 3 times a negative 14, I get a 249 over 6. Now, the square root of 249 is not going to be nice. So I am going to get a decimal approximation here, 2 decimal approximations, one with a minus, one with the plus. So if I go negative 9 plus the square root of 249, and I divide that by 6, I get about a 1.13. When I take negative 9 minus the square root of 249 and divide that by 6, I get a negative 4.13. So those are going to be my 2 x coordinates, approximate x coordinates. I am then going to put those 2 numbers, this one here, into here, and this one here in. So when I do that and I put in my 1.13, so I have a negative, basically 1.13 plus 3, I get a positive 1.87 when I put that in. When I put a negative 4.13, that actually is going to make it a positive 4.13 plus 3, I am going to get for that one a 7.13. And so these are going to be our 2 points of intersection, approximate points of intersection. On number 5. So for this one, we have a regular polygon with an exterior angle, okay, external angle that is 18 degrees. So if I have that being 18 degrees, I know that the angles, the exterior angles of any polygon add up to 360 degrees. Okay, that's the sum of exterior angles. I am going to divide that by 18 degrees to see how many sides that is. And 360 divided by 18 is going to give me 20 back. So I am going to get 20 sides. So this is going to be a 20-sided polygon. Now for this polygon, each edge has a length of 12. Okay, so each edge has a length of 12. What is the length of the radius of the polygon? So basically, I am going to have a triangle, an isosceles triangle, and that isosceles triangle is going to have a side length of 12. I know that the angle that is going to be formed here, because I have 18 of these, right? I have, sorry, 18 of these. I have 20 of these. I apologize. That this is going to be 18 degrees. Basically, whatever your exterior, a single exterior angle is, that's what your central angle is also going to be, because it's also 360. Okay. And it's going to be divided by 20 sides. And that's going to give me 18. Now, the radius is from the center of my polygon, my 20-sided polygon, to a vertex. So that's what I'm trying to find. Now, if that is 18 degrees, what that means is when I have my triangle split, in half, okay, so when I split this in half, I am going to be splitting that, and this is going to be 9 degrees, 9 degrees. Okay, make sure it looks like, I'll just put a 9 there, so 9 degrees. And this is going to be half of that 12, which is 6. And what I am trying to find is this length right here. So if I am using this 9 degrees, I know opposite, I want to find hypotenuse. So I can take sine of 9 degrees is equal to opposite, which is 6, over hypotenuse. Okay, that's what I'm trying to find. Or here, I'm going to call that, because it's supposed to be the radius. Okay, so I'm going to call that R, because it's supposed to be the radius of this. And I'm going to do this math. So when I do this, I'm going to get R sine of 9 degrees is equal to 6. I'm going to have R is equal to 6 divided by sine of 9 degrees. I'm going to put that into my calculator, making sure my calculator's in degrees and not radians. So 6 divided by sine of 9 gives me about 38.35. And so inches, that's going to be the length of the radius. On number 6, we want to find the total surface area and the volume of this. Now, first thing I'm going to do is I've got this right triangle here. I know one side is 3. I know the hypotenuse is 5. So if I did Pythagorean, I'm going to see that this is a 3, 4, 5 right triangle. So what that means is if I'm trying to find the area of the triangle, okay, where this is a, whoops, still running in triangles, where this is a 3, this is a 4, this is a 5. The area of that is going to be base times height, which is 3 times 4 divided by 2. So this is going to be 6. For the volume, I'm going to take that 6 and times it by the height of 7. And I'm going to get my volume is going to be 42 meters cubed. Okay, so this is going to be 42 meters cubed. Now, when I'm trying to find the surface area, I know that for the surface area, I am going to have that 6, that triangle. Okay, I'll do it in pink. That's the triangle. I'm going to have that triangle twice, top and bottom. So I'm going to have at least 12 so far. Then I have 3 rectangles all the way around, and I can do this one of 2 ways. Okay, I'm going to show us 2 ways to do this. I can go 3 times 7 for one of the triangles, 4 times 7 for, not triangles, sorry, rectangles, and 5 times 7. So I'm doing each of these faces here. So that's one face. That's the 5 by 7. This is my 3 by 7. And this is my 4 by 7. And compute that. Another way to think about this is taking that 2 times 6. And instead of finding each of these rectangles separately, think about the perimeter of the base. The perimeter of the base is going to be a 3 plus a 4 plus a 5, or basically 12 when I add that up, and times that by 7, and that's the same math. Okay, so either way I do it, I am going to end up with 96 as my answer. Okay, and this is going to be 96 meters squared. So the next one is a pyramid. So I have to be careful. It is a pyramid. And I want to find just the volume for this one is all they're asking. Now, sounds easy, right? But I don't know the height. That 15 is not the height. And I have to be careful when I'm trying to work this out. There's a couple different ways I can go about it. So in this situation, let's see, I know that the base is going to be 12 times 9, which is going to be 108. That's going to be 108. Okay. Now I want to find this height to the center of this. And I'm going to draw this to that lateral, or I shouldn't say that slant height. Okay. Or that lateral edge, if you want to think of it as that. So when I'm doing this, what I'm going to need to do is I'm going to need to find that value. So when I'm doing this, let me redraw this out where I've got 9 here and 12 here. And I am going from the center of this basically out to here. Well, instead of finding that, what I'm going to find is, and I'll do this in a highlight, all the way from here to here, using the idea of Pythagorean theorem. So I have a right triangle, I have a 9, I have a 12, and I need to find that other side. Now, this is going to be a 9, 12, 15 going all the way across, because some of us might recognize this as a 3 times 3, a 4 times 3. So that is a 5 times 3. So it's really a 3, 4, 5 right triangle with a scale factor of 3. But again, you can do Pythagorean theorem. Okay, so now what I need is not the 15. I need half of 15, which is going to be 7.5. So the distance from here to here is going to be 7.5. And so I have another right triangle where I'm trying to find that height. So my right triangle that I'm going to be using, this is going to be my height. This is going to be 7.5. This is 15. And here's my right angle. So I'm going to do Pythagorean. So I am going to take 15 squared minus 7.5 squared is equal to h squared. And when I put that into my calculator, I get 225 minus 7.5 squared. I get 168.75 is h squared. I am going to take the square root of this. And when I do, I get a 12.99 about. So that h is a 12.99. Okay, this is going to be that pink height So now to find my volume, I am going to take the base, okay, this base, 108, okay, which is this whole entire rectangle base. So I'm going to take the 108, I'm going to times it by the height that I just found, 12.99. That would be the prism. I don't have the whole prism. I have a pyramid, so I'm going to divide it by 3. And so when I do that, I end up getting, let's see, 108 times 12.99 divided by 3, I get 467.64. And did they give us any units? They didn't give us units, so but this would be units cubed as my answer. On number 8. Okay, so on 8, we have a couple of bits of information here. We know the surface area of this prism, of a prism, is 190. We know the volume of that same prism is 150. What we're going to be doing is reducing this so that each side is 1/3 as big. So we have this ratio. I'm going to put it right here. R squared, R cubed. And I'm going to write above it. So my R is going to be 1/3 because my sides are going to be 1/3 as big. My surface area is going to be 1/3 squared, or 1/9 as big. My volume is going to be 1/3 cubed, or 1/27 as big. So I am going to take the surface area, which is 190. I am going to multiply it by 1/9, or basically divide it by 9 is the same. And when I do that, I'm going to get a 21.1 repeating square centimeters. Okay. Then I'm going to do the volume. My volume is 150. I'm going to times that by 1/27, which is basically going to be dividing it by 27. And when I do that, I get 5.5 repeating centimeters cubed. On number 9, we have a right triangle that has a regular rectangular base. The base edges are 6. So let me just draw that in here. So all of these are going to be 6, okay? I'm just going to draw one of them in. We know that the lateral edges, okay, that was our 6. We know that the lateral edges are 10. So the lateral edge, for example, would be this, okay, and that is going to be 10. And we want to find a couple things. First thing we want to find is AG. So AG is going to be from here to here. So in this picture, I do have a right angle here, and I'm going to form a right triangle. So I'm going to color code. So my right triangle is going to go from here to here, here to here, and maybe I won't do that in, I'll do that in a teal color, because it's not going to be that whole thing, it's going to be that portion right there, okay? And then I know this. So this is my A, this is my G. Sorry, that looks like a 6. This is my G. This is a right angle, and this is E. So I know that A to E is 10. I know that all the way across that base was 6, so that this portion here is going to be 3. And then I'm going to do Pythagorean to find that height. I'm just going to call it X right now, okay? So x squared plus 3 squared equals 10 squared, or what I'm going to do instead is I'm going to do 10 squared minus 3 squared is equal to x squared. So that's 100 minus 9, which is going to be a 91. So x is going to be the square root of 91. So that is the length of AG. AG is going to be root 91. Okay, then they want us to find AF. In this picture, AF is going to be from here to here. So that is going to be the height of my pyramid. Now, I can use this and connect it to different spots, but where the spot I'm going to connect it to, I'm going to connect it to from F to E. And you'll notice I'm drawing that in purple. The reason I'm drawing that in purple is because I have a hexagon, and let me just get a hexagon real quick. Okay, so I have a hexagon, and in this hexagon, this is going to be my B. This is going here. I'm just going to do it in black. So this is going to be my B. This is going to be, I'm going to make it a little thinner. Okay, this is my B. This is my C. This is my D. This is my E. F is here in the middle. Okay. Now, when I'm drawing from F to E, that is going to be an edge of one of the equilateral triangles. So this is 6, this is 6, this is also 6. So that's why in the picture I drew it the same color as I did from D to E, because it is the same length. Okay. So the right triangle I'm going to be using, I want to find this. I'm going to, sorry, make this a little thicker now. Okay, so I want to find that height. I know that if I go out here, this is 3. And I'm going to be using the orange because I know that, and it's a nice number as opposed to the one I just found. Okay. So that's the triangle I'm drawing. And so in this situation, this is going to be the height of my pyramid. So again, 8 squared plus 3 squared equals 10 squared. What I'm going to do instead is I know that h squared is going to equal basically 10 squared minus, sorry, that's not, I put 3, that's not 3. That's the purple, sorry. That's the purple, the whole way across, right? Here to here, here to here. So that's 6. Sorry about that. So that's going to be 10 squared minus 6 squared. So I'm going to get h squared is equal to 100 minus 36, which is 64. So my height is going to be 8. Okay. So AF is 8. And some of us might have, again, recognized this as a 3, 4, 5 right triangle where I'm doubling. So I double that and I get 8. Okay. Okay. So I've got that information. So I know the height of my pyramid. I'm going to skip down to D first because D, I'm going to need to find the base area in both problems, okay? But all I have to do for the pyramid is find the base times the height divided by 3. So I'm going to zoom in here. And again, we have that that base, okay? And for that base, again, I am going to be going from here to here to here. That is 6 and 6 and 6. So what's going to happen is if I find the distance from here to here, okay, that's going to be the height of this. Now, this is an equilateral triangle, which means now I have a 30, 60, 90. So this height right here in my triangle, this is now going to be 3. This is a 6. And this height here is 3√3. So to find the area of one of these triangles, okay, one of these triangles, I'm going to take my base, which is 6, my height, which is that 3√3, divide it by 2, and I have 6 of these. So when I do that math, I get 54√3 for the hexagon area. Okay, that's what I get. That's my base area. So I'm going to take that hexagon area, which is 54√3. I'm going to be multiplying it by the height of the pyramid. And the height of the pyramid was my green A to F, which was 8. So I'm going to times it by 8. And that would be this as a prism. It's not a prism, it's a pyramid. So I have to divide by 3. Now, when I do that math, I'm going to take 54 divided by 3, which is 18 times 8. I get 144√3 for my answer. And this is going to be cubic centimeters. Okay, that's going to be my volume. So for the next one, the surface area, I have the area of the I have the area of the base, and I need to find the, so I know that my hexagon has an area of 54√3. Okay, that's my base area. I need to find the area of each of the triangular faces. So let me just get a triangle. Now these triangular faces are going to have a base of, sorry, I should do it in purple because I had it as purple over there. A base that is 6. We found that AG, okay, AG is my pink one. That actually is the height of these lateral faces. So that pink height is √91. So to find the area, total surface area, I should say, I am going to take my 54√3. I'm going to add on to it the area of these triangles. Now I'm going to have 6 of these triangles, and each of these triangles is going to be base times height divided by 2. So I'm going to have 54√3. 36 divided by 2 is going to give me an 18√91. And this is going to be centimeters squared. And that is going to be my answer for the total surface area. Okay. I'm just going to clear that so I can read the next problem. So on number 10, we have a cylinder that has a volume of 75 cubic centimeters. We know that the height of this cylinder is 3. We want to find the base area. So if I want to find the volume of a cylinder, I'm going to take the base area, which happens to be a circle, times it by the height, and that's going to be my answer. Now, I know that the volume is 75. I know that the height, so I'm going to put B for base area. I know that the height is 3. So I need to find my B. So I'm going to divide both sides by 3, and I get that the base area is going to be 25. That is my base area, 25 centimeters. Okay, that's my answer. Okay. Now, what is the radius of this? And this is where you got to be careful. So my base was a circle, and the area of a circle is pi r squared, and the area of our circle is 25, not 25 pi, 25. So I'm going to divide both sides by pi, and then I'm going to square root. So I'm basically going to be taking this square root of 25 pi to get my answer. So 25 divided by pi is about a 7.96. I'm going to square root that, and I get that my radius is 2.82 centimeters. That is my radius. Okay, on number 11. So in this situation, this is one where we have to write the equation for both of these graphs, these sections. One is a parabola, one is a line. And we have to give some restrictions because we don't have the whole entire parabola, and we don't have the whole entire line. So if I'm looking at this one here, I'll do it in orange, okay? So if I'm looking at this parabola, I want to pay attention to where my vertex is. Okay, my vertex is at 0, -2. And then you want to be careful with the scale of this. Notice that what's happening is we are going out 1 unit and up 1 unit. And when I went out 2 units, I went up 1, 2, 3, 4. So this is a regular parabola with a regular stretch of just being a 1. So this particular graph here is going to be x squared minus 2. Okay, y equal x squared minus 2. But I have a restriction on that. So when I do this, it's going to be f of x is equal to x squared minus 2. And you'll notice that it's going to the left forever. And it's stopping, but not including 1. So it's going to be x is less than 1, not including 1. Then I need to figure out my line. So my line, what I probably would do is the following. I am going to, you can go backwards and find your y-intercept. I'm not going to bother doing that. I'm going to look at this point. This point is 1, 2. So I'm going to write this in kind of point slope form. I know that how am I moving from point to point? Well, in this situation, I am going down 2 over 1, down 2 over 1. So my slope is going to be a -2. And then I have this point. So I'm going to put it in like I do for a parabola. X minus 1, that's moving it to the right 1 for that point 1, 2, and then my plus 2. Now you can clean that up if you want. I'm just going to leave it like that. I'm going to leave it as a -2 times the quantity x minus 1 plus 2. And then I have this from 1 on, including 1. So I go 1 is greater than or equal to 1. On number 12, for this one, I know that this line QP, okay, this line QP has a point of tangency at Q. So if I was to draw from Q to O, that is going to make a right angle with that line. I also know that ON is 4. So ON and OQ are both radii of this circle. So this is going to be a 4 and this is going to be a 4. I know that NP from here to here is 1. And we want to find QP. So I'm going to have a right triangle. And I know that this is going to be 4. And this is going to be a 4. This is going to be a 1. So that means this whole entire thing is going to be a 5. And I need to find the green. Let's just call it X. So I'm going to do Pythagorean, but I think we'll recognize this as a 3, 4, 5 right triangle. So that answer is going to be 3. And that's the end of the video.